Hey everyone, in this video, let's take a look at question 125, valid palindrome on Leetcode. This is part of our blind 75 list of questions, so let's begin. In this question, we are given a string and we want to determine if it is a palindrome or not. Not only that, we have to do some pre-processing first. First of all, we have to convert all of the uppercase letters into lowercase, okay? So first of all, convert string to lowercase, okay? Secondly, we have to remove all non-alphanumeric characters. Remove all non-alpha numeric characters, right? So this includes everything like maybe it includes like a space, maybe it includes like something like this, maybe like all of these like non-alphanumeric characters, everything like this, okay? And so basically after all of that is done, if then it is a palindrome, then we return true. Otherwise, we return false. So let's just take a look at this example over here, all three of these examples. So in the first example that we have, well, first thing we have to do is we have to lowercase everything and we have to combine it. So we lowercase everything, then we remove the alphanumeric characters, which is like something like the space over here, the comma, the colon, etc. So we have this, and then we can determine that this is a palindrome. Here, after we remove everything, we get this, but this is actually not a palindrome because we have like this thing here. And this one, an empty string, after we remove it, it basically is a palindrome, right? Because we'll just have something like this, and so empty string is a palindrome. Okay, so we know already how to determine if something is a palindrome or not, right? What we can do essentially is that we could, let's consider something simple. Let's say we had string race car. We could have two pointers, right? I, j, and essentially what we want to check is we want to check that I is equal to j, the item at I is equal to the item at j. And if that's the case, we'll go inwards. And if they're still equal, we'll go inwards. And then we'll go inwards, etc. Right? So basically, the thing that we're looking to see is that I eventually crosses j, or j crosses I. If this is the case, then we know that every element on basically the boundaries and working our way inwards has been correct, has been basically the same. And so if we cross, then we know that the entire string must be a palindrome. If at any case we run into a situation where they're not the same, then we can go ahead and return false. Okay, so let's maybe go ahead and start with that. So how can we start with that? Well, first of all, we note that an empty string is a palindrome, right? So we can do something like if not s, return true, right? Okay, now let's ignore this lowercase part just for now. Let's just ignore it, right? So how would we do it otherwise? Well, otherwise, we just have left is equal to 0, right is equal to length of s minus 1, and we would do something like this. While L is less than R, then if S at L is equal to S at R, then we would increase L, we would decrease R. Otherwise, we would return false because it's automatically not a palindrome. And if we get out of this while loop, then we return true. So this would work for a regular palindrome, right? This would work for something like race car. This would also work for something like, so let's say race car is a valid example. Maybe here it's something like, I don't know, like EF. So in this case, it's actually not a palindrome. So we can try that out. And we get the correct answer there as well. Okay, but that's not what we're asked here. We're asked to basically like remove all of this stuff, right? So we have to lowercase it, and then we have to alphanumeric, like do this thing here. Okay, so one thing we could do is we could actually like go through the string and remove all of these characters and, do all of these things, right? But we actually don't need to do that. We can actually just modify this. And if we run into scenarios where like we have a comma or like capital, we'll just handle it there. So let's see, how do we handle this case here? Convert string to lowercase. Well, that's easy. We can just, instead of s at l, we can just do s at l dot lower, right? So we can do something like that. So that handles the first case. Now, what about this one? Remove all non-alphanumeric characters. How can we handle this? Well, we actually have a function in Python that can actually check this for us. So we can do something like if s at l dot is alum, I think it's called. I have to actually check alphanumeric Python. I believe that's the function. Is alphanumeric. Okay, so that's the function. Is alphanumeric. So something like this, right? So if s is alphanumeric, then we are good. But if it's not alphanumeric, then we don't really need to consider this L, right? We can just move forward. So for example, if we arrive at a comma, then we don't need to consider this. Let's just move forward. We'll just move forward here. We can also check like if not s at r dot is alphanumeric. then we could decrease our R, right? We could do something like this. And we can actually do this both in the same iteration. So we can actually just check something like, let's see, invalid, and we'll set that equal to false. And so here, invalid is true. Here, invalid is also true. So then we can just do if invalid, then let's just continue, right? Let's just continue. We'll continue to the next iteration. We don't want to check this because it's possible that even after increasing the left pointer and decreasing the right pointer, it's still not an alphanumeric value, right? So we don't want to just check it yet. We'll check it in the next iteration. And so now let's go ahead and run our test cases. And we see it passes. Let's go ahead and submit. And we also see it passes. Perfect. So in this example, what we have in this code, our time complexity is O of n because we're just going through the list ones. We're not storing anything, so space is constant. Okay, thanks for watching.